Hi guys, how are you doing? In this video we'll finally move to work on the undo buffer. In order for the program to be useful, we need to be able to press Ctrl Z and undo it. Undo the previous actions, and Ctrl Shift Z so we can redo them potentially. All the professionally done applications have such functionality, and our own should have that as well. So in this video I'm going to show you how that could be done with diagrams. I had time to think about it over the night, and I figured out how I want to do it. I'm not sure whether what I want to do will work, because right now I'm not completely familiar with the capability of the Blazor diagramming library, but it is worth a try. Originally, I mentioned that it could be worth doing it using immutable data structures, but we aren't going to go for such an approach. Instead, we're just going to have something like a stack, and on it we'll put 5 union types: the node create, node delete, link create, link delete, and the move operations for the nodes. So that's 5 union types we'll have to implement. And then if we want to undo, all we'll just do is pop the last action of the stack and revert it and revert the diagram using that action to the previous state. We'll put it on a separate stack, which will be the redo stack. So for example, if we press Ctrl Z, we'll be popping things off the undo stack, and when we press Ctrl Shift Z, we'll be popping things off the redo stack. We'll also put in some limits. We'll figure out how to do that later. We'll also have to figure out how to keep the images around. I mentioned that we might go back to base 64 just for this, and we'll probably be doing that. Using blobs is more efficient for storage, but we aren't doing something like an art gallery for our own site. So base 64 might be more suitable for an application such as this one. Now, what we will start is we'll take this HelixDiagram class and convert it to F#. Right now it's fine, but since we will be implementing the undo buffer in it, so doing that in F# will be a lot easier. For that sake, we'll convert it to F# entirely. Let's do that. We have the Helix fun. We'll make it a type. We'll put it somewhere here. Actually, we won't copy paste it. Let's just start it from scratch. Type HelixDiagram. We'll put in an underscore so the types aren't conflicting right now. Okay, inherit diagram. See, we already have the diagram in scope. Oh, now we need these variables. We need a constructor. Let's start with the constructor. IJS runtime. JS. Whoops. We'll make it all lowercase. Now we need to register the model components. Do. We'll make a do block. This might be it should be Alright, we cannot actually do that here, unfortunately. We'll have to think about this a bit. Where can we register the model components? Maybe on index startup. No, it should be done in the class itself, but maybe when it's made in program CS, something like here. Okay, I thought about it a bit, and I know what I want to do. The component registration should be done here, but we'll make it so that the HelixDiagram class, instead of inheriting from the base diagram, it will inherit from whatever we'll implement on the F# side here. So maybe we'll make it this HelixDiagram base, something like that. And it will inherit from that. Then we won't need to register the components here. HelixDiagram base. No, we don't need this. I mean, no, yes, we actually, this is exact. I mean, this in particular is what we need. Base, we should be passing. Oh, it also takes the diagram options. Okay, we'll put the ops here. JS runtime. Oh no, we have yeah, the diagram options are a static field. We'll move that to the F# side, or maybe we can just leave it here. I mean, it doesn't really matter. Yeah, we'll leave it here because C# has better autocomplete for properties. And then none of the things here matter for the functionality in particular. Maybe this, but it won't have any effect when we do the implementation of the base class. Okay, so we'll pass in the options, we'll pass in the runtime. Base. No, we don't need to pass it here. Yeah, these are the diagram options. We don't need this. Okay, so is first equals true. Oh, we'll do it a bit differently on the F# side. Let immutable is first. Let's make it easily loaded. Oh, then async task on load. Okay. Remember this on load. If not is loaded, then we'll do what's in the diagram. Yeah, it needs to be a task. Is loaded is true. Okay, do. pass this in. So yeah, it's good that the task also can wait on the value task. Maybe the value task inherits from task, I'm not sure. Now we need to do this. Unlike in C#, I don't think F# will be can await on the inner fields. I mean, like this. This is one of the places where I'd say C# is better. Store load. Actually, we'll have to put it in front of the store load module. Let nodes. Why did I make a small JS? I should have maintained it big. Let links. Oh, nodes, links. Oh, whoops, I got rid of the curly brace. We'll just press F2 and rename it to uncapitalized JS later. Oh, now what's his problem? Diagram, nodes, string, links. I see. Actually, it's interesting that this comes up to 3 lines of code, and it also comes up to that in C#. Actually, in C# it's 4 lines of code, because it's using the parentheses. That's pretty interesting. That F# is that F# is less verbose even in situations where you would not expect it. Okay, remember this. I mean, I know I'm just hyping F#, but I do like the language and wish it was more popular. I mean, imagine if it was more widely used on the job market. That would be good for me. Maybe if I was doing freelancing, it wouldn't matter what kind of technology I was using. But who knows how things will turn out. Right now I'm not really good enough to actually attempt it. If is loaded, then let nodes links do this is great. Oh, now we also need this on before unload. JS in vocable. You don't need to put an attribute suffix in F#, even though the autocomplete will try to make you do that. And maybe it just didn't have it imported, so that's why it put the full name of the attribute. This, let's not make a mistake. Anyhow, the method should be named task on store. Yeah, just on store. Yeah, in F# it asks us to put a full name. Maybe that's because, maybe that's for the sake of better type inference. Train task unit. Oh yeah, we don't need to wrap it in a task, since this already returns a task. And the time for this will automatically be inferred. Yeah, this is great. Okay. We'll get rid of all of this. Oh, now we'll try running it to see if everything still works as expected, like last night. But should we? Yeah, I shouldn't be running Helix, but no, actually I should. For some reason, I really should put this into its own project. Instead, it was just put in the Blazor folder. I'll do that. I'll fix that later. Yeah, Chrome is our default browser now, since the Bing is so useful. Yeah, everything seems to be working. If I reset it, yeah. Perfect. Now we can start to work on the undo buffer. We'll do that in F#. I'm going to click on this. Now let me pause a bit so I can think about this. Okay, let's go over our plans. I've gone over the diagram component, and it has the events we need to use. For example, inside the nodes layer, we have the added and removed events. We can subscribe to those to detect when a node is being added to the layer and when it's being removed. We'll use these nodes to add references to the node models into the undo buffer. The same goes for the links. It has an added and removed event. The individual nodes are a bit more difficult. Now where is the node itself? Node. Oh yes, here's the node. We have a node here, and it has some events: change, moving, and size changed. Obviously, the moving event is what we'll need to use when the node moves to detect those changes. But for detecting when the movement starts and when the movement ends, we can't rely just on this. Instead, we'll have to make use of the diagrams mouse down and mouse up. Oh, here it is. Mouse down, mouse up. Mouse down should be the trigger to start detecting the movements and the mouse up will be the trigger to end detecting the movements. Once the mouse is released, we'll take stock of all the movements that have occurred for the individual nodes and add them to the undo buffer. It also has touch start and touch end. We'll maybe accounting for those will also be a good idea. Now, none of these methods have any kind of documentation. So, for example, the event here, I'm not sure what it does. Maybe it just triggers when the property for the node changes. Who knows? This is something I should ask the author. In fact, let me do that. Blazor diagrams. Dance GitHub. Blazor diagrams. What does the changed event do? Excellent. Now let's get back to the application. And just for adding and removing the nodes, it shouldn't be too difficult. The only tricky part is that when we are doing the replay buffer operations, we'll have to remove and add the handlers afterwards. Now, okay, let's make a type. Type replay. I keep saying it's a replay, but I mean to say undo and the redo buffer. Undo buffer. Actions. You node added of node model. You node removed of node model. You link added of node model. You link removed of node model. In addition to this, I've been wondering when where I should put the positions, and probably every time the nodes gets added. So that way, let me think what I want to say. Okay, I was just thinking how to deal with positions. There are various things we need to think about. For example, suppose we have the replay buffer, and we press the mouse. The way I'm thinking of implementing detecting for movements is I showed you that the nodes have the moving event, but it might be better to just completely ignore that and instead use the mouse down event on the diagram itself. When the mouse down gets pressed, we could iterate over all the nodes and get their positions. Those are just points. We could put them in a dictionary of all, map all the nodes to their positions. That would be an easy way of storing all the positions at that particular point in time. And then the user could, move the nodes around. It could even move several of them at once. That's something we need to think about carefully. Then when the mouse up event gets triggered, we do the mapping again. We map all the nodes to their new positions. Then we compare them with the positions in the first dictionary. That is how we could get the deltas. If the delta is 0, then the node hasn't changed its position. But if it has, then we can just we could put them in this undo buffer actions. Nodes moved of dictionary, node model, position, or actually point. Thank you, Ryder. Dictionary. Let's make this the starting point. Start and whoops, and is a keyword, so we'll put an underscore. Now that's how we could do things. We'll have a let's say 2 stacks for. I mean, I'm thinking how I could implement limits with the stacks, and it wouldn't be that. I don't think the stacks have the ability to, take from the other end. We'll check it out. Undo stack, and this is in system collection generic. It's really good to not have to re-implement these basic data structures like Fable required us. You have pop, pick, push, ensure capacity. I mean, we could just use a resize array. I think those act like stacks. But you know what, we'll use the stack for now. Who cares about the limits? If the memory runs out, let it. Redo stack. We'll just overload the pop and the pop methods later to ensure capacity. We'll replace this stack with a resize array. But for now, let's just implement the functionality that we need and make sure it's correct. Okay, now, yeah, we have these actions. Yeah, we should subscribe to the events. This and yeah, we need the nodes. Then added. It's asking me to add an action. Full mix. Then let's say undo, add, undo push, and that would be node edit x. We can just I mean, I'm tempted to write this in a functional style with like edit, undo push, or something like this. But I don't want to do that because we have to clear out the redo buffer whenever anything gets added. So the undo one. Oh, this nodes and removed. Is the same thing as before. Let's just put it all in one line. No need to take up space on the screen. We'll do the same for the links. Links. Then a link added. Link removed. This should be a link model. Or maybe the base link model. I wonder if there's a base node model. There isn't. Okay, base link model. We'll use this one. Great. Now let's factor this out into a function. Let's add layer handlers. Later, when we do an undo action, we'll want to remove these handlers so they don't get triggered twice. Add layer handlers. Great. Now we'll also want to do the opposite and add the remove handlers. Remove layer handlers. These nodes. Touch car. That remove added. Remove added. This is for removing the node models. We can't just clear it out. Can we? In the C# version, let's say links, we have this event. Why is it bothering me with this? We have add. Yeah, it only has the add and remove methods. Okay, I guess I will have to handle node add x. Let handler node remove x. Let handler link add handler link remove x. Great. Now we'll also remove the same handlers. Remove. You know, I really hope this actually works. It could almost just, take these and then convert it to an action, which would result in a different reference. So that's something to keep in mind. If this doesn't work, we'll have to make these explicit actions. In fact, why risk it? Let's just do that. Action fun x. Why is it compiling? Maybe it's expecting this kind of action. Yeah. I mean, maybe it would work without this, but who wants to mess around with this later? Now we know that it's an action. Can't forget the fun x. Great. And now we can be sure this will do exactly what we want. Okay, now let me just pause so I can think what's next. Yes, we have the handlers. Now we just need the undo and the redo methods. Remember this undo. We'll first check out whether there's anything in the undo buffer. If undo count is greater than 0, then we'll actually do something. What we will do is remove all the handlers first. Then we will execute whatever is in the undo buffer. We'll get the last action. Undo pop. Or what we could have simply done is undo add try pop. Undo try pop. Yeah, but that would end up complicating things when we replace that with a stack. I mean with a resizable array. So let's do that normally. Let act. We'll push it into the redo buffer. Redo push act. Then we'll pattern match on the action act with. We'll go through all the cases. I wish it would just fill out the cases itself. But it's not good enough. I mean, the rider ID is not good enough to do that at the moment. Now, yeah, we need, if the node has been added, we need to remove it, obviously. So, okay, we need to go over the nodes. Now we need to find this particular node. Yeah, we need to remove. I mean, it has exactly what we want, and this is great. Now new node removed. Let me just make it X. This nodes add X. Now we'll do the same thing for the links. Link added X. X. This links remove. I don't really need this parentheses. You link added, I mean link removed. This links add X. We also need to take care of the movement. You node moved, nodes moved. I don't think the start should be the start isn't a keyword, but interesting that it just replaced it with this. So maybe, okay, we could don't do that, and now we have to move the nodes to where they have started. So in fact, we don't even need a diagram for this. We just seek iter start seek iter. This is a key value. We'll use this active pattern matcher. KV. Oh, I forgot the fun. We also need the parentheses around this. Now, for every key, position is B. Yeah, this is pretty good. Oh yeah, we also need to put back the handlers. Add layer handlers. Now comes the redo function. Redo will remove the handlers. Will pop from the redo stack. We'll push it into the undo stack. Then once again we go through all these cases, except we do the reverse. Remove, add, remove. Now instead of the start we go through the end. And thank you, Ryder, for auto-completing that. You did a good job. Yeah, that's this should be that should be it for these two functions. So now we need to make sure when the key Ctrl Z is pressed so that this gets triggered, and Ctrl Shift Z that the redo gets triggered. How can we do that? Let me pause a bit so I can look into it. Okay, I thought about it a bit. The diagram component has the key down event, so we'll just use that. It doesn't have the key up, and the key press is deprecated, so that one doesn't matter. Let's just do a bit of refining for fun. Instead of this, maybe a more idiomatic way of writing this this part would be to use a for loop. For in do oh yeah, there's an extra parenthesis, unclosed one. Okay, so it is a bit more concise and readable like this, isn't it? Now we'll just add a handler to one key down. I wonder if we could just, for example, overload it. Over on key this on. I guess we can't do this on add key down. And this particular handler we won't need to remove, so we can do it in a line. Okay, let's make this EV. This is code. Oh, it has the Alt, Control and Shift. Oh, this is great. If EV and EV now what's the key? What's the repeat? Oh, I see. So this event will in fact trigger multiple times if it repeats. I see. I didn't know that. As I said, I'm new to web development relatively, so I'm not familiar with the APIs just yet. It would be a good time to get in touch with those. So do we use code or do we use key? And let's try the key. For example, if key equals z, maybe that could work. In fact, you know what, let's just print fn s ev key ev. We'll use an interpolated string ev key ev code. Ev code. We'll compile this and test it out. I'll close Chrome. Oh, now let's open the DevTools console. Key A. Oh, I see. So what we want is the first one. Where is it? Oh, wait there, scroll down. Oh yeah, here it is. Yeah, we want the key. Okay. If ev shift key and ev key equal, I mean, it doesn't need to be equal, but just this, then, and I mean, I did this exactly here. Then, sorry, we'll call this undo. Why is it? It needs to be an equal sign here. F-sharp's equality, unlike C-sharp's, is structural equality. So, for example, if you want to use reference equality like in C-sharp, you'd have to do something like no, not equals, but EV no, but system object reference equals, and that will give you the reference equality between two objects. I've used it on occasion, but structural equality in general is much more useful. Now, why don't we add? Why don't we also add Control Shift so it calls redo? And if we Shift key is Z, redo. Yeah, this should call redo. Perfect. Oh, now it can restart the application. We'll see what happens once we do that. Alright, we haven't really implemented the movement part in the replay buffer. What did we do? Alright, we haven't yeah, we haven't done the movement. So, but we can test the addition and deletion. Let's try this. I'll press Ctrl Z, nothing happens. Let's open the console. Ctrl Shift Z. Oh, it came back. But if I make a new component and press Ctrl Z, nothing is happening. If I press Ctrl Shift Z, nothing is happening. If I, for example, remove this, Ctrl Shift Z, now it's toggling it. This is not good behavior. This is not the behavior that we want. So we'll have to figure out what is going wrong. Oh, it's clear. Yeah, it's clearing the redo. No, wait. Why is it clearing the redo here? Yeah, it should. Yeah, it should be cleaning the redo. Then if we undo it, let's go over it step by step. First, whenever we do anything, printfn undo. It will print whenever we try undoing, it will print the replay, the undo buffer, the undo stack. I mean. I'm pressing Ctrl Z here and nothing is happening. If I add two text nodes and I press Ctrl Z, nothing is happening. Ctrl Shift Z, nothing is happening. Why is nothing happening? Print fun, no. Yeah, I noticed that there is a small Z here. I really got tricked. Maybe we could do lower. two lower. No, we don't need the two lower in this first part. Why am I complicating things here? Checking for shift key is superfluous, but actually what could happen is that the caps lock could be on, like for example, right now on my keyboard I press caps lock, and the letters will come up in uppercase without me pressing shift. So what do I want to do about that? Do I want to automatically, you know, convert to lowercase, or do I want to just leave it as it is? We'll do it like this. We'll make it caps lock invariant. Now, okay, let's recompile it. I'll remove this one, press Ctrl Z. And it is undoing the undo. If we look at what is going on here, oh, it's adding a link model. How weird. Okay, let me restart. I'm confused by this. We'll add a text, we'll undo it. Nothing is happening when I do it. Suppose I erase it and then undo it. This is not at all like I imagined how it would be. Okay, in the handlers we'll have to add some print statements, no other choice. Adding node, removing node, adding a link, removing link, oh, it added 4 nodes and a link. I see, I see, I understand now. When it loads, it's actually all these nodes get triggered in the undo buffer. If I add a node, it has added a node, and then if I press Ctrl Z, nothing happens. Okay, that's that nothing is happening is a bigger problem. Oh, I pressed Ctrl Z twice and now it worked. Wait, why did it call removing node so many times? When I add a node, it called adding node 5 times. Why is that happening? When I remove it, it removes 5 nodes. And suppose I add a node, then I add another one and another one. Are the handlers getting called multiple times with the same node for some reason? Let's just put a print statement here. Print, I want to make sure adding handlers removing handlers. Yeah, it adds the handlers. If I press Ctrl Z, it actually removes the links. And then it adds the links. It adds the links twice for some reason. Oh, maybe it adds them on both sides. So that's why it gets called. And this is a much weirder behavior than I expected. I'm perplexed as to what I need to do about this. Now it's adding a node 3 times, 6 times. Last time it was 5. If we restart it, it's adding a node once. Wait, maybe I'm pressing Ctrl Z here. Now if I add a node, it still adds it once. It removes it. It adds it 3 times. Now it's adding it 3 times. Are the handlers not getting removed properly? What? This is really very perplexing. Suppose I remove the link, it removes the link, it removes the node. If I undo it, it removes the handlers, adds them. Oh, it actually triggers before it adds and removes it. Oh, now there's a floating link here, so that can happen. I see. What is happening is that the remove handlers isn't working as expected for some reason. That can be the only conclusion. I wonder if this is a problem with the library. Oh, there's an easy way for us to test this. For example, we have the remove we have the add handlers here, and if we also remove them right afterwards, remove layer. I pressed F1 by accident. What is this? Sorry, I tabbed into the wrong thing and closing the entire browser. Let's open the console. It's adding the node. Yeah, it has added the handlers, then it has removed them, but the adding node and adding link still get printed. Okay, now the only question is, am I doing something wrong, or is the library itself doing something wrong? I'm going to have to ask the author this. Let me pause here. Okay, let us resume. We got an answer to our question from earlier from the author. He says that it's meant for Blazor to know when to call state has changed to update the UI. Now, I opened an issue. Handler removal doesn't work. And here is the explanation. Anyway, I've tested it, and it seems they get fired right away instead of being queued, so that will allow me to use a mutable variable as a switch to suppress them, instead of removing them like this. That's what I will do. Okay, let's mutable is handler active false, and this would be a good thing to have at the start, but it should be true. Okay, if it's true, yeah, we don't need this action anymore, since we are going to be removing them. Well, if is handler active, then okay, we are going to be factoring some of this out. We can't. There's no point in handler node. Okay, let's do it. Handler template x fx. Now we'll factor all this out. U node added x. We can do it like this. Actually, focus me. Maybe it wouldn't be bad to add an argument so it doesn't return a function directly. It would be less indirection like this. And then if we inline it, it will improve performance, but because it won't need to create a closure. But it seems local bindings cannot be inline. Whatever. Who cares? This isn't a place where we need to care about performance. Yeah, in that case, let's remove the arguments. Just using an indirect call to a function is less expensive than creating it every time. Oh, great. It's in the handlers, it's removing the handlers. Yeah, we don't need to remove them anymore. We are lucky. We don't even need to have them inside the statements. Oh, wait, what am I doing? This is not good. You know what, let's not factor them out too much. Or maybe... Okay, we will. This is the right thing to do. This is perfect. We do need to replace this with something, and that something is handle active false, and here it should be true. False, true, and as I said, I tested it, and this should work. I mean, I thought it would be queued in some. It would be queued on some message loop, like in the UI, and then it would get fired only on a later rendering cycle, but that isn't the case here. I figured it out, but by looking into the printfs, by adding the printfs. No. Yeah, we will press Ctrl+Shift+S to compile it. Why did it exit? Stupid thing. Did it crash or something? Okay, let's reload the DevTools. We have no choice. Let's just terminate this console, then we'll run it again. CD Helix. Now if we add a text and add it again, then Ctrl+Z, it works. Ctrl+Shift+Z, he doesn't. If we add an image, then Ctrl+Z, Unfortunately, it doesn't remove it. Text. I'm pressing Ctrl Z, but nothing is happening. I guess we'll have to figure it out. Where do we put the print statements? Node added, node removed. I shouldn't have removed all of the print statements, but that's fine. It's not a big deal. Press undo. Pressed or redo. Let's recompile it. Pressed undo. Oh wait, did I remove it? Press redo and the link is not coming back. Oh, it says pressed undo and pressed redo. Okay, this should be else if. How silly of me. We'll erase this one, erase this one, erase this one, then press Ctrl Z. Then if I press Ctrl Shift Z, what just happened? It keeps saying that I pressed redo. I see. Oh, this is such an annoyance. Okay, let's with Z when evo control and evo shift. Control this undo. If it's something else, then do nothing. I'm gonna have more keys in the future, so it's good to do this right now. We'll add a text node. We'll add a link. We'll add some other node. Press Ctrl Z. I'm pressing Ctrl. Yeah, it now finally registered. Then if I press redo, it works. I'm trying to press redo. So for some reason it maybe the canvas became unfocused. If I do it here, for example, yeah, it works. Now I'm pressing Ctrl-Shift-Z and nothing is happening for some reason. Maybe we should be attaching this to the main window. This kind of event handler. I'm not really sure what. Okay, I mean, here it became here it's not responding to the redo again. Neither is it responding to the undo. I wonder where are the properties? Oh, I see. It's also undoing the replay buffer on the component itself. I didn't think about that. So if I unfocus, yeah, unfortunately it triggers on the component. So I have to think about this a little bit. Let me pause here. Okay, here's what we are going to do. Let's go into the text component, and we'll stop the key down from propagation. From being propagated. On key down, stop propagation. Let's recompile it. Now suppose I write something here and then undo it. Great. Let's remove this. We'll write something in here like QE, Ctrl Z to undo it. Then if I click on the diagram, great. Oh, I see. Because for some reason, notice how when redo stopped working, this became focused. If I press Ctrl Z, this became focused. And now it isn't working. Why is this component becoming focused when I press Ctrl Z instead? Yeah, the diagram, when I press Ctrl Z, the diagram changes. So it changes what it's selecting. So we'll have to figure out how to select one of the components. For example, if we add a component, we should select it, maybe. I mean, could we somehow select the diagram itself? Unselect all. Unselect the model. Oh, this could, we could do. Let's try using this. Unfortunately, as you can see, this component got selected. And now nothing is working anymore. How could I get the diagram to select itself? Just one question. If I select a component, the text field itself doesn't get selected automatically. Oh, right now I selected this, press Control and press Control Z, and this one got selected. Okay, let me pause a bit. I need to play around. I don't understand why the selection is switching the way it is. I'll be right back. I figured out why the text field is getting selected auto turn. For example, when I do this, then I remove this, then I press undo. Notice how it undoes the text here. That causes the text field to get selected. So what we need to do is somehow suppress the key down event from where it is from this handler to going into the components, but I can't see a way to do that. What should I do here? I have no idea. For this I'm going to have to ask the author. Be right back. Okay, I opened this issue and hopefully we'll get an answer from the author soon. But for the time being, we'll ignore it and move on to other things. I mean, this is just an annoyance right now. It's not really preventing us from working on other functionality. So that's what we'll do. We will... Yeah, we need to take care of the movement right now. We still haven't implemented that. After we do that, I guess the only thing left will be the component properties. And we will think about what we want to do with that when it comes to it. Okay. Let me think. Node smooth. Yeah, we need to on mouse down. Yes, on mouse down. That's what I said I would do. Add on mouse down. Phone EV. When the mouse is pressed down, what we'll do is iterate over all the nodes in the node layer. Nodes. This. We didn't need the coordinates. This nodes. Let's seek, choose. Okay, this X is a node. Now we need to check if it is selected. If it is, if selected, then some X, else none. What this one will do is give us back a sequence of selected nodes. Then, why are we getting a type error? Action model mouse event arcs. So maybe it has 2 arguments. What is this model thing? And this model, is it a link model? Is it a base model? I'm not sure what it is. Anyway, it doesn't really matter. Let's do what we need to do. Then, yeah, we have the list of selected nodes. I'm going with the assumption here that only the nodes that are selected can be moved, and that the only way to move the nodes is either by using the replay buffer or moving them manually using the mouse. I'm just been distracted right now. I'm thinking that we should disable being able to use the replay buffer while the mouse is pressed down. So yeah, we should suppress the replay buffer functionality. Sorry, I keep saying replay buffer, but it should be okay. When I say replay, I mean undo and redo. I'll try to stick to saying undo. So now how do we want to suppress them when the mouse is down? Okay, we'll have some mutable is mouse down. Yeah, I mean is false. Okay, this should be true. Then we'll suppress it like this. So maybe we should suppress all the handlers when the mouse is down. Okay, let's just go with this for now. We can always change it later. Okay, we'll also do the opposite of this. Do this, add mouse app fun mouse down equals false. Now what I want to do is make a dictionary. Let mutable selected nodes is known. We'll use a null here. And we'll actually make this the start nodes. Nodes movement start. Dictionary. And this isn't the most efficient way of doing it, but it will... Yeah, who cares about an extra object allocation or two. Match dictionary. Yeah, we need also to match them to the key. Yeah, this is just a node right now, but we also need the node and its position. So that should... why isn't it working? Collection key value pair. Okay, let's make it a key value pair. Some key value pair. Yeah, great. These are the node movements. Start. We'll also make it... we'll iterate over these actually this time. Sequence map. Key value. Okay. We will... let's just do it in the most straightforward way possible. We'll just map it to the same thing. Let's make this X. We don't need the value. I mean, what we're doing here, we could do it all in the same loop. Let nodes movement end. Now, what I want to do is check if any of the nodes have moved. If they have, then we'll just then we'll send the message to the undo buffer. We'll push to it, and if it hasn't, then we won't. Easy peasy. Let's we now need to compare the two dictionaries. Sec exists too, and it's great that this exists. Fun key value p1. Oh, oops. P2. Then I don't think P1 equals P2. I don't think yeah, we need to node movements start, no movements end. We also need to set this to null. I mean, not just yet, at the end. Because it changed. I think this will result in a reference comparison. Does it have an equals? I mean, it has an equals for all I know. We'll leave it like this actually, and then if it causes problems, we'll come back here. And just okay, we will just print has changed. B. Okay. And if it has changed, then undo, push U, or what was it? U not smooth. U not smooth. Nodes movement start. Nodes movement end. I mean, this is a really imperative programming, but I can't really do anything better than this since we are using events. No. Yeah, this should do it. Okay, and let's just add some print statements. Print mouse down pressed, triggered. Mouse up triggered. Oh yeah, if we pass empty values to node movement start and node movements end, what will happen? Let's check that. Let's check that out quickly. We'll use a script file. Script. Seek from AB equals B. Seek exists too. I'll press Shift Enter over this, and it returns false. This is great. This is what we want. If we did a for all, for example, yeah, it should be true. Yes, I just needed to remind myself of that. Okay. This is great. Now we can maybe compile it on its own. Let's see. Mouse down triggered has changed false. Mouse down triggered has changed false. Mouse down triggered has changed false. That's not what I want. Maybe this P1 X equals P2 X and P1 Y equals P2 Y. Why is this giving us an error? Point. Instead of doing that, let's move this to the left side. That way the type inference will know what the types are inside the lambda. We'll make this a tuple. Now it knows that this is a point. We don't need to add that type annotations to them. Has changed false. Okay, let's now let's movement start. I just want to see whether it selects anything. Yeah, it does. Oh wait, what did I do here? I'm checking whether there are. There's something pretty stupid. Actually, let's go all the way back. This should. I'll check for changes like this. Has changed, true. Has changed, false. Has changed, true. Suppose we select both of them. I mean, I don't have any highlighting to show which nodes are selected. I'll add that data later. But now it works. If we try to undo it, press undo, nothing works. I'm pressing redo and nothing works. Have they actually moved? I move it. Has changed true. I press undo. Nothing happens. But if I click on the diagram, the nodes move. So maybe we have to just refresh the diagram. I wonder how that works. Let's sorry, I'm not focusing properly. Okay, where is K position equals V? Maybe if we just K set position. I think I saw this. Why is this a problem? Yeah. Oh yes, this is in fact a point. So why is it telling me that it needs one? It's expecting to have a type float. Can I K refresh? Okay, refresh. Maybe refresh all. I'm not sure. Okay, we'll do a refresh. Okay, refresh. And we'll see what happens. Ctrl+Shift+S, it's recompiling. Now we'll check it out. I'll move this, press Ctrl+Z, and it refreshes. Great. Let's try moving both of them. Now both of them should be selected. I'll move it somewhere like here, press Ctrl+Z, and great. Now the move functionality for the undo buffer works. If I press Ctrl+Shift+Z, unfortunately that isn't working. Well, maybe yeah, now even regular undo functionality isn't working. For example, if I do this, and I press Ctrl+Z, I mean, if I press on the canvas, then press Ctrl Z, press Ctrl Z. The undo works, but if I redo it, it doesn't. And this started causing a problem since we added this. Let's try commenting these out. Is mouse down? Oh, now let's try adding this. Ctrl Z, Ctrl Z. Redo. Redo isn't working, but it was working before. We forgot equals false here. Okay, great. Now we'll comment this in again. Let's erase this. Ctrl Z, Ctrl Shift Z to redo. Now if I Ctrl Z and Ctrl Shift Z, yeah, now it works. Great. This is perfect. Let's move both of them. I'll press Ctrl Z, Ctrl Shift Z. It works. Oh yeah, this is pretty great. We have some pretty good undo buffer functionality now. Ooh, what's going on here? Ooh. This one works, but this one doesn't. Oh, why does it think? Huh. Okay, I didn't expect this. If I restart it, it works. If I undo it, the link ends up being messed up. Oh, okay, so I didn't think about this. What if we tried doing maybe refresh all? Maybe the links need to be refreshed. K links refresh for L in K links. Do L maybe refresh. We'll also try doing that in the redo. And maybe refresh all doesn't mean to refresh literally everything, just everything in the particular node. That would make more sense. Okay, I'll try moving it here, then undo. No, the links are still messed up. Oh, never mind that. Okay, let's try refresh all. We'll recompile it. Now Control Z. The links are still messed up. I'm not sure. Maybe this is another issue I should open on the HelixDiagrams repo. Okay, maybe. Okay. Oh, there's a refresh links. This should probably take care of it. But refresh also should also refresh the links, I think. So yeah, it doesn't work, unfortunately. Reinitialize ports, maybe. Oh, let's try this. We'll leave that in for now. Oh great, now it works, now it works. Oh yes. Now let's just do that. Go back to a regular refresh. We are really duplicating code here. Let's just let nodes moved. Okay, or maybe no, just the dictionary. I'll just make it start. Okay, is node model. We'll rename this to D. Nodes moved. Start. Nodes moved. And this is not that great. I guess we need to refresh all and then reinitialize the ports. Yeah, this is wonderful. Now we have the movement functionality in the redo buffer. As you can see, it works. Oh, now I guess yeah, now the only thing we have left to take care of are the component properties. For the text node, yeah, the components themselves actually have. Oh, what's this? Core helix nodes line 175. Oh, I see. Oh yeah, come to think of it, the null errors. Let me just pause a bit so I can think about it. I'm trying to dig up a memory, but I can't do it. Anyway, this error, I think it's happening because if the mouse up event happens without the mouse down, then this could very well be null. In case you're wondering why the mouse up event could happen without this, maybe it could be propagated from child components. We clicked on a text component, I think. On mouse down, stop propagation. Yeah, that's there also should be a mouse up. Okay, let's do it. Mouse up. Mouse up. And we should be using this on all. Yeah, everywhere where we should be using mouse down, we should also be stopping mouse up from propagating. And as a safeguard, we're going to check for nulls. If yeah, this should be good enough. In fact, instead of using this boolean here, we only really need the dictionary to not be null. Then let's make that let is mouse down. There should be a function. Maybe it could also be a property. We could also make it a property, but never mind that. But not wait, it must, if now if the mouse is down, then this should not be null. If mouse down, but the reason I'm doing this is it's less for the sake of abstraction and more for the sake of readability. Oh, now everything should be fine. Oh no. Okay, now what do we have to do next? Let's press Ctrl+Shift+S. It will recompile. Yeah, the bounce up triggered as soon as I pressed on this and released it. But now it isn't propagating, which is what we want. Well, here it is. Okay. Now, what was I saying? Yeah, we could take care of the properties here. I mean, in the undo buffer from the diagram. But the property also has its own undo buffer, for example. So I'm not sure about re-implementing this functionality. An image node. Oh wait, why is the... Yeah, it got selected. Okay. And the key, using the keys for the redo and undo is really unreliable right now. Okay, this is a good time to pause for me. I need to have breakfast, so I'll think about it for a bit and then tell you the conclusion. See you soon. I had breakfast and I had the time to think about it. First of all, I think that the individual components having their own replay buffers is, undo buffers is interesting. Yeah, this is not bad behavior. This is quite good. For example, there's nothing wrong with having being able to undo the individual components instead of having them be globally. So another concern of mine are images. Unlike text, images are really big. Depending on the resolution, they can be megabytes. For example, in a single chapter of a web novel, you can have hundreds of them. So I want to make it so that this entire diagram can be used as a document for storing images. If I add a replay buffer on top of all of that, it would need to hold all the images it has seen, as far as it can, and that could lead to the program quickly running out of memory. I simply don't have the option here of doing, I don't know, memory management wizardry. So I'm not going to have a global undo buffer. What we've done today is actually very good. This is an excellent functionality minus this annoyance where it selects the previous text field. Hopefully the laser diagrams author will give me a positive answer on how to resolve that. Now, this video is already over 2 hours long, so we are going to cut it short. Let me just say what we need to do from here on out. What we need to do is deal with images. All of the images that we have should be not in a local host or not in outside URLs, but they should be in blob storage, so that later we can just serialize them to some kind of document format. maybe it would be good for us to get rid of local forage and bring in some kind of IndexedDB library that could store the data in a binary format. We should definitely look into that. And let me think. Yes, that's what I want to do next. That would be saving and loading of images. That will be the subject of the next video. I don't think I'll be screencasting it live like this anymore because it rapes my hard drive space very hard. So I hope you enjoyed this brief moment of me talking to you personally, face to face, and I will see you in the next video. Bye bye.